Look up at the night sky. Every star, every planet, every galaxy you can see adds up to just 5% of the universe. 5. The other 95%? It's completely invisible, and we genuinely don't know what it is. But here's what most people get wrong. That missing 95% isn't one mystery. It's two. Two utterly different things, with confusingly similar names. One acts like an invisible glue, holding the cosmos together. The other acts like an invisible force, tearing it apart. They are dark matter and dark energy. And today, we're going to settle, once and for all, exactly what makes them different. Because they share that word dark. Dark matter and dark energy get blended together all the time, even though they do almost opposite things. Dark here simply means invisible and unknown. Neither one gives off light, and neither has ever been directly identified. But that's where the similarity ends. In the next few minutes, we'll break down exactly what each one is, the rock-solid evidence that they exist, and the single most important difference between them. We'll even reach the cutting edge, where brand new results are challenging what scientists thought they knew. Let's start by looking at the universe's true budget. Let's put some numbers on it. Everything we can see and touch, every star, every galaxy, every atom in your body makes up only about 5% of the universe. Dark matter accounts for roughly 27%, and dark energy makes up the lion's share, around 68%. Put differently, the stuff we actually understand is a rounding error. The universe is overwhelmingly made of things we've never directly observed. Now, those two big slices behave in completely different ways, and the easiest way to tell them apart is to ask a simple question of each. Does it pull things together, or push them apart? Let's take the puller first. Dark matter was first suspected because galaxies were behaving impossibly. Galaxies spin, and by all rights, the stars on their outer edges should fling off into space. There simply isn't enough visible matter to hold them in with gravity. Yet they stay put, orbiting far faster than they should. It's as if something unseen is gripping them. That something is dark matter, a vast, invisible mass woven through and around every galaxy, providing the extra gravity needed to hold them together. We can't see it, because it doesn't emit, absorb, or reflect light. But we can see its gravity at work, bending the path of starlight, shaping galaxies, and binding enormous clusters together. Dark matter, in short, is the cosmic scaffolding. Without it, galaxies as we know them couldn't exist. So what actually is it? Here's the honest answer. We don't yet know. Scientists have ruled out the obvious candidates. It isn't just faint clouds of gas, or burnt-out stars, or ordinary matter hiding in the dark. The leading idea is that dark matter is made of an entirely new kind of particle, one that barely interacts with normal matter at all, passing straight through you, this planet and everything else, as if it were a ghost. Right now, billions of these particles may be streaming through your body every second. Teams around the world have built ultra-sensitive detectors deep underground, hoping to catch just one. So far, none has been definitively caught. Dark matter remains invisible, all around us, holding the universe together, and still unidentified. But it has an opposite number, and that one is even stranger. Now meet the other 95% mystery, and it pushes instead of pulls. In the late 1990s, astronomers set out to measure how fast the universe's expansion was slowing down. Everyone assumed gravity must be gradually putting the brakes on. Instead, they found the exact opposite. The expansion of the universe isn't slowing, it's speeding up. Something is driving galaxies apart, faster and faster, overpowering gravity on the largest scales. Scientists named this mysterious driving force dark energy. Unlike dark matter, which clumps around galaxies, dark energy appears to be smooth, filling all of empty space evenly. And the more space there is, the more its push adds up. It's the cosmic accelerator, with its foot pressed steadily on the gas pedal of the entire universe. Which brings us to the heart of the matter. So here's the single distinction to remember, the one that cuts through all the confusion. Dark matter pulls. Dark energy pushes. Dark matter works with gravity. It's extra invisible mass that draws things together, builds structure, and holds galaxies and clusters in place. Dark energy works against gravity. It's a force woven into space itself that drives everything apart and accelerates the expansion of the cosmos. One is the glue, the other is the anti-glue. One sculpts the universe into galaxies and webs. The other stretches that web ever thinner. They're not two versions of the same thing. They're cosmic opposites locked in a struggle. And the outcome of that struggle decides the fate of everything. Picture the history of the universe as a tug-of-war. Early on, when everything was packed close together, dark matter's gravity dominated, pulling matter into clumps, building the first galaxies and the great cosmic web. But as the universe expanded and matter spread thinner, dark matter's grip weakened. Meanwhile, dark energy, filling all that growing empty space, kept getting stronger in total. A few billion years ago, dark energy took the lead, and the expansion began to accelerate. If it carries on as a steady force, the future is lonely. Galaxies drift ever farther apart, until distant ones vanish from view entirely, leaving each region isolated in the dark. That's the standard prediction. But brand new evidence has thrown a fascinating spanner in the works. For decades, scientists assumed dark energy was a constant, the same unchanging push everywhere for all time. But recent results from a major sky survey, which built the largest 3D map of the universe ever made, have hinted at something startling. Dark energy might not be constant after all. The data suggest its push may have been weakening over recent cosmic history. Now, a crucial caution. This isn't confirmed. It hasn't yet reached the strict statistical gold standard that physicists demand before declaring a discovery, and on its own the standard model still fits. But if it holds up as measurements improve, it would be revolutionary, forcing a rewrite of our model of the cosmos and reopening the question of how the universe will ultimately end. We may be watching a genuine scientific turning point unfold in real time. Step back and consider how remarkable this is. 95% of the universe is invisible, and yet we've mapped where it is, measured how much there is, and worked out what it does, all without ever holding a single piece of it. We know dark matter holds galaxies together because we can see its gravity at work. We know dark energy is pushing the cosmos apart because we can watch the expansion accelerate. We're standing in a universe made mostly of mystery, and rather than being defeated by that, human curiosity has charted it in extraordinary detail. The darkness isn't a dead end. It's the greatest frontier in all of science. So let's bring it home. The visible universe is just 5% of the whole. Dark matter, about 27%, is the invisible glue. Extra mass that pulls things together and holds galaxies in place. Dark energy, about 68%, is the opposite. A mysterious force that pushes space apart and accelerates the universe's expansion. Dark matter pulls, dark energy pushes. That's the difference in a nutshell. Both are invisible, both are unidentified, and together, they make up almost everything that exists. And with fresh hints that dark energy itself may be changing, the biggest chapters of this story are still being written. If this finally cleared up the difference for you, do me a quick favor. Hit that like button. It really does help these ideas reach more curious minds. Share it with the friend who always mixes the two up. And if you want to keep exploring the universe's deepest mysteries with us, subscribe and ring the bell so you never miss what comes next. 95% of the cosmos is still waiting to be understood, and we're only just getting started. Until next time, keep looking up.